In the last video, you learned about metallic bonds and how the electrons are shared with all atoms in the metal or metal alloy. In this video, you will learn about covalent bonds, in which electrons are essentially shared between specific atoms that form a bond. A covalent bond results from the sharing of electrons between two atoms that have similar electronegativities. This normally occurs between two nonmetals and most often includes nonmetals and metalloids from groups 14 through 18. Properties of covalent compounds include the fact that they are discrete molecules, unlike ionic compounds, which were atoms arranged in a crystal lattice. If the molecule is polar, like sugar, it is soluble in water. If it is nonpolar, like octane, it is not soluble in water. Many are gases, such as propane and ammonia, or liquids, such as water and octane. Solids are often softer and more flexible, although some can exist as crystals, such as sugar. Most do not conduct heat or electricity well. They are better insulators. Examples include water, sugar, acetylsalicylic acid, which is aspirin, hydrogen peroxide, propane, ascorbic acid, which is vitamin C, and isopropyl or rubbing alcohol. Before you can start drawing the Lewis structures for covalent compounds, you need to know some definitions. The central atom is the atom in the center of a covalent Lewis dot structure and is usually the atom written first in a chemical formula. Note that carbon is always the central atom, but hydrogen is never the central atom. A single bond occurs when two atoms share one pair of electrons. The bond is usually drawn as a single line. Examples include the bonds in fluorine and water. A double bond occurs when two atoms share two pairs of electrons. The bonds are usually drawn as a double line. Examples include the bonds in oxygen and carbon dioxide. A triple bond occurs when two atoms share three pairs of electrons. The bonds are usually drawn as three lines. An example includes the bonds in nitrogen. A lone pair is a pair of electrons not involved in bonding. They are typically drawn as a pair of dots in the Lewis dot structure. If you look at the Lewis structure of chlorine, for example, you can see that there are three pairs of electrons and one single electron. The pairs of electrons are going to be the lone pairs. The single electron is the one that will be involved in bonding. There are exceptions to this general rule, but we will not learn about them in this class. Pause the video and write down the steps to drawing a Lewis structure for a covalent compound. You will learn how to apply these steps in the examples that follow. The first example is chlorine, or Cl2. There is no central atom because there are only two atoms total in the molecule. Chlorine is in group 17, so each chlorine has 7 electrons in its Lewis structure. The total number of valence electrons in the compound should wind up being 14. The single electrons are the electrons that will bond. There are exceptions to this rule, but you will not have to learn them in this class. Notice that the single electrons are lined up, getting ready to be shared between the atoms. The final Lewis dot structure will show the two chlorine atoms close together with the bonding pair of electrons between them. Notice that when the atoms are sharing their electrons, it's as if both of them now have a complete octet, which was their goal in the first place. Another way to show the bonding pair is with a line. The line in the Lewis structure represents two electrons being shared between the two atoms. Notice when you count the number of valence electrons in the final Lewis structure, the number is still 14. The next example is ammonia, or NH3. Nitrogen will be the central atom, and the hydrogen atoms will be placed around it. Nitrogen is in group 15, so it has 5 valence electrons. Hydrogen is in group 1, so each hydrogen has 1 valence electron. With 5 valence electrons from nitrogen and 1 from each hydrogen, you should wind up with a total of 8 valence electrons. Notice that hydrogen does not want a complete octet. This is because only 2 electrons will fit on the first energy level in the electron cloud. When hydrogen has 2 electrons on the first energy level, it now looks like helium, which has a stable electron configuration. Here is the Lewis structure with the lines showing the bonding electrons. The third example is carbon dioxide, or CO2. Carbon will be the central atom with an oxygen on either side. Carbon is in group 14, so it has 4 valence electrons. Oxygen is in group 16, so each oxygen has 6 valence electrons. Adding the 4 valence electrons from carbon with the 6 valence electrons from each oxygen gives a total of 16 valence electrons in the Lewis structure. If we draw only one bond between the carbon and each oxygen, notice that there are single electrons left over, and none of the atoms has a complete octet. We want every electron to have a partner, and for the atoms to have a complete octet. If we instead basically swing some of the electrons around so that carbon can form a double bond with each oxygen, each atom now has a complete octet. Here is the structure with lines representing the bonding electrons. If you take AP Chemistry or Chemistry in college, you will learn that carbon dioxide, as well as many other molecules, have something called a resonance structure, which is another way that the electrons are sometimes distributed in the molecule. We are not covering resonance structures in this class. Pause the video and try to draw the Lewis structures for the following compounds. When you are finished, continue the video for the answers. In this video, you learned how to draw Lewis structures for covalent molecules. In the next video, you will learn how to determine the shapes of covalent molecules. Thanks for watching.